All right. Well, what we're going to do here is we're going to go through a couple problems where we're going to be looking at how to identify what a certain trig function is by given a graph. Okay, so the first thing is when you're looking at a function, a trig function, the key things are you want to try to identify what are the different attributes. One thing that you can look for right away is what is the line of oscillation. And right here you can see the line of oscillation. Usually it's this indented point, and it usually starts at 0, but in this case you can see the line of oscillation is at 2. So what does that mean? When you compare the graphs, that means when you're looking at your function, that line of oscillation actually equals the d value. So when we're looking at this, y equals a function a f of b x plus, sorry, minus c, all right, minus c plus d. D, that vertical shift is going to be the line of oscillation for its cosine or sine function. Next thing you want to do is let's find the amplitude, all right, from the line of oscillation to the peak, all right, or the valley, all right, wherever that distance is, that is going to be a, or the absolute value of that is going to be a. Well, you can see that value is going to equal 1, all right, and so we have an a value that, at least the absolute value of the a value is going to equal 1, okay? The next thing we want to do is we want to figure out our b value so we can find our period, okay? So the first thing is find our d, we can find our a. Next we want to find our b, okay? Now to find our b, we have to find the period. The period is located when the trig function repeats. So if we start right here, we can see that this goes from here, and we see another one right there, so it goes from 0 to 2 pi, so that distance, all right, that is the period, and that period is 2 pi. Well, normally we have 2 pi, and if you recall, all right, we can find our new period is 2 pi divided by b. And since our period is already 2 pi, our b value then is going to equal 1. Okay, so our b value is going to equal 1. All right, because we have that for 1, so we have b equaling 1. Okay. All right, and that equals 2 pi. There you go. So b equals 1. So looking at all these different values, we can see, okay, we have 1 right here. We have some that are negative. All right, we have a d value, which is 2 here, here, and here. So that narrows that down. We also have a b value of 1 in every single one of these. So now the question is this sine or cosine? All right, so the third question, or the last question is this sine or cosine? Now, one thing you can remember or look at is what is the phase shift, okay, the phase shift. And really, that is what we're going to look at next, all right, the phase shift. So if we look at this right here, we can see that we have at 0, it starts at this one value. So it looks like for a cosine function, the cosine function appears there is no phase shift. If anything, we would say cosine function would be shifted over pi units to the right, okay, this right here. Okay, so we could say right there, boom, 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 boom. You maybe could say that we maybe are moving this pi units to right with the negative right there, but this is pi units to the left, all right? And so really, maybe this could be, so I guess we can maybe say it's going the other way as well, so I guess that could be a possible solution. But another one is if we look at, so cosine appears that we would have a phase shift, all right, to the right, okay? So I'm looking for right pi units, okay? Here though, sine, it appears that this is going to a phase shift to the left, okay? So this is for cosine. But for sine, if we look at this, a phase shift, usually it starts right here and it goes up, but you see that that part right there is at pi over 2. So it appears there is a phase shift to pi over 2 units to the right, okay, to the right. Phase shift to the right would be that we have a c value, since our b value is this one, so we would have a b value of 1. So really, and it's also going down right here, and so we would need a negative a value, okay? So it's reflected. So we see that's reflected as well. Okay, so looking at this, we see that, yes, the sine function is going up 2. It is phase shift to the right pi over 2. It has an a value of 1, but it is reflected. So it appears maybe the best answer, at least looking at this graph that they give us right here, would be B. All right, B. An argument could be made for maybe D, but I would think B would be the better argument. Okay, cool. All right, well, let's try out another one. Okay, let's check out another one. Let's try this one right here. I'm going to change my color. I'm going to get this red. Okay, so going through the same process, the first thing is let's find our line of oscillation. So the first thing, find a line of oscillation. We see it right here. Okay, it's going up and down at 0. So that means D is 0. So you can see that all these values have a D of 0. Next thing, let's find our amplitude. All right, our amplitude. All right, so we're looking for our amplitude here. And in our amplitude, we're going from the line of oscillation to the peak and valley. We can see that it's going to equal A equaling 4. All right, or the absolute value of that equaling 4. All right, so our A is probably going to be 4 without a reflection. So that is 4, 4, 4, and 4. This has a reflection here, right there, and these do not. Okay, so let's just figure this out. The next thing is, all right, number 3 is, let's see if what is our period. Okay, what is our period? So looking at our period right here, we can see that this is pi over 6. This is going to be 2 pi over 6. All right, and this is going to be 3 pi over 6, which is pi over 2. So we can see from here, up and down, and then starting right there, it is going from here to there. All right, and what it appears to be is 1, 2, 3, 4. 4 pi over 6, which appears to be, all right, 2 pi over 3. All right, so 2 pi over 3 appears to be our period. Okay, 2 pi over 3 is our period. Okay, now, if you recall, okay, 2 pi over 3 is at a period. 2 pi divided by b is a normal period of sine or cosine, and this is what this function probably is. And so, since this equals 2 pi over 3, we can see that our b value, all right, 2 pi over 3, and that equals 2 pi over b. So we can see that our b value, it has to be 3, okay? And so looking at this, we either have a 3 here or a 3 there, and so these cannot be it. Now, from here, we want to figure out what could this be. Now, if it's cosine, well, cosine means this is going to be shifted to the right or left. So the last thing is we need to figure out if this is sine or cosine. So now we're going to look at our phase shift. Okay, our phase shift. Now, on this one, it has a phase shift right here of, remember, it takes c divided by b. And so we're going to have pi over 2, and we're going to have actually negative pi over 2, because that's our c value, divided by 1/3, okay, or divided by b, which is 1/3. So we have a negative pi over 6, negative pi over 6. So there is no reflection here. So if we go right here and we go negative pi over 6 right there, that appears that could work out, okay? It has a cosine function up 4, and it goes through the whole entire cosine period of pi over 3. So it appears that D would work out. Let's see what would happen here. For this one, we have basically the same thing, except this one is going to move, all right, pi over 2. Notice it's a negative, so it's going to be to the right, okay? This negative means going to the left. So maybe we should put there left, okay? This one right here, pi over 3 multiplied by 1/3, that gets pi over 6, and this is moving to the right. So this is a phase shift, all right, to the right, pi over 6. So if we take this one and we move it pi over 6, well, you notice that pi over 6, if we move the sine function, pi over 6, it's not a sine function, it's a cosine function. So literally this one appears at D, whatever your answer, this is our best solution. Okay? So once again, these are the kind of the 4-step process, the success criteria if you're used to that. All right. 1, find the line of oscillation. 2, find the amplitude. 3, find the period. That helps you find your B. Then figure out the phase shift to help you figure out if it's cosine or sine with the given information. All right, let's try one more. Okay. And we're looking at 4 right here. I'll change my color again. Let's go green. Okay. Now on this one, once again, let's find our line of oscillation. Line of oscillation appears to be at y equaling 0 again, so that means D is 0. Okay, so all of these has D of 0, so we're good. 2, next thing we're going to do is find our amplitude for our A value. Amplitude going from here to here appears to be 2. Okay, so A is going to be 2, or at least the absolute value of A is 2. All right, let's go from there. So this and this would be okay. These are knocked out of the running because they have 4, so that's not right. next thing is let's find our period. Okay, let's find our period here so we can find our b value. Going from here, this is pi over 8. So pi over 8, 2 pi's over 8. All right, so 3 pi's over 8, and then 4 pi over 8. All right, and we have that right there. So from here to here appears to be 4 pi's over 8, which would give us pi over 2. Pi over 2 would be our period. All right. Knowing that we have 2 pi over b, that's going to equal pi over 2, because that's our new period. Okay, and so what do we have there? We realize that b is going to equal 4. Okay, b equals 4. Okay, so looking at this, b equals 4. And, well, looking at those two, we see that b equals 4. This is not it. All right, so let's just see for the final thing is, can this be, so this one is knocked out of the running. Okay, so b has to equal 4. And so the last thing is for, is there any phase shift? And let's just verify, because we do have a none of these right here. So phase shift there, well, if we start right there, that is where sine goes, and it goes up. So yeah, this definitely is a sine function. All right, sine function. So it appears there is no phase shift. There is none right there. So we may say 0. So yeah, B would be the correct answer for that one. So that would be sine 2 sine of 4x would be that particular thing. All right, so I hope this helps you out in identifying this. So once again, find the line of oscillation, find the amplitude, find the period that helps you find your B, use that and compare it to your values that are given, and then finally look at your phase shift, determine what your A and what if it's going to be sine or cosine. Okay, well, that is what we got here, and I hope this helps you out, and good luck and God bless in the rest of your problems.